wanted to show you this very fascinating image. What you're looking at is the image of my computer screen, which has a direct image from the camera on my microscope. So this is actually a sample that is on my microscope right now. And this is what I would call a white blood cell symplast. A symplast simply means a sort of aggregating together of elements. And in this case, the elements are all neutrophils. And as I speak to you, you can actually see them moving. And so this is a really good illustration of how white blood cells communicate with each other. They've all been called to be in this one area, and they will have crawled through the blood sample to meet and come together here. This sample is an aged blood sample, but it's from a client who has particularly vibrant white blood cells. I mean, these white blood cells, these neutrophils are very active. I'm just taking a photo. These white blood cells are very active, and I think here, let me see if I can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 cells in one area. Now, this particular area on the sample may well have some kind of pathogen growth in it. And so therefore all these white blood cells have been picked up the signals and been called towards this area. Or what could have happened is one of these white blood cells may well have enveloped a bacterial pathogen or a virus or something, or a small parasite. It may well have engulfed something, and then what happens once it does that is it sort of digests whatever it's engulfed, and that's what these white shiny granules that you can see moving do. They're full of enzymes and hydrogen peroxide and things like that, so bleach. They literally do dissolve whatever it is that they engulf, because that's how they clean up the trash. You can actually see, I'm going to put my arrow here, there's some bit of trash here where that arrow is. Can you see it? And the white blood cell is extending itself towards it. It's almost chasing it. So I wonder if there are some rather interesting chemicals in this blood sample in this area, and maybe all of these white blood cells have engulfed it. And once it gets inside the cell, once it's inside the cell membrane, it's been engulfed and it's almost there. These white granules will start to dissolve it and break it down. Once it does that, it may well put out a signal in its membranes, or put out a chemical in to call other white blood cells to the area for help. So when you see this much activity in a blood sample, it's definitely a sign of immune system activation because of some form of perceived attack or pathogen or toxin, something that's not supposed to be in the blood. And that actually is a very long list of things, and it's possible, the possibilities are quite huge. So this isn't a diagnostic, this is an observation of what is going on inside this person's body. Something's happening, it's stimulating the immune system, so much so that this is happening in this blood sample even 4 hours later. So on one hand, it's a sign that yes, there is some energy. The immune system has energy, it has the resources to deal with it, because these are very healthy white blood cells. They are healthy, they are moving, they're well defined, they've got bright granules, the granules are streaming, and the nuclear lobes are quite well defined too, they're not fuzzy, and the membranes are quite well defined. It's very healthily produced white blood cells, but there's something going on, and that's why they're all congregating together in this one part of the sample.